Hi! So in this video, we're going to be reviewing energy, work, and power. We're going to review some basic principles, the formulas, and practice using those formulas with calculations. Alright, so of course there's a law involved. There is a law of conservation of energy, and all that means is that energy is always conserved. Energy cannot be created or destroyed. I'm sure you're familiar with this law. Energy can change form, but the total amount remains the same. So for this pendulum, here at its highest point of swing and here at its highest point of swing, you have maximum potential energy, meaning there's no kinetic energy. It's almost like it pauses here, then it changes direction to swing back down. At this point in the middle, it has maximum kinetic energy. So if you remember back to middle school, kinetic energy is that moving energy. At this point, this ball is moving the fastest. Here's another example. Christopher Robin's holding this ball. So here, he has potential energy at the very top where he's holding this ball. He has potential energy because he's up some height with this ball. Gravity's going to pull the ball down if he were to let go. Here on the right-hand side, he does let go. He lets go, and all that potential energy is transformed into kinetic energy because the ball is now moving. If it's moving or in motion, it is kinetic energy. All right, so let's compare kinetic and potential energy. So potential energy. If we're talking about potential energy, we are talking about mass and position. Those are two things that the object depends on. If the object has a mass and it has some position, then it does hold potential energy. Usually when we're talking about these scenarios, the position is going to be height, h, and of course m for mass as always. All right, if we're talking about kinetic energy. If we're talking about kinetic energy, again, we're talking about moving energy. So the object, again, has mass, but then now it's moving, so it has some sort of speed. Speed, or in this equation, v for velocity. All right, when we calculate for kinetic energy, we use this formula. So kinetic energy is equal to 1/2 mass times velocity squared. Now, only the velocity is squared in this equation. So only the speed gets squared. All right, when we talk about potential energy just says that there is energy that has the potential to change into something else. It could be because maybe the object is at some position. Maybe it's up on a hill. It has some sort of height. It could be the internal structure, the chemical composition. So it's some sort of stored energy until it's converted to something else. Because remember, energy is not created or destroyed. There are several different types of potential energy. We will mostly be talking about gravitational potential energy. So due to gravity. But there is also chemical, nuclear, elastic, electric. But again, we're focusing on gravitational. Here, the girl on the swing. If you were to measure her potential energy, down here, not that much potential energy. A little bit, because she is raised up off the ground. She's that high off the ground. But when she starts swinging, her potential energy increases because her height increases. So when we're talking about gravitational potential energy, it all depends on the height of the object. The higher the object goes, the more potential energy that you have. All right, so to calculate gravitational potential energy, and it's due to the position above Earth's surface. So you have the surface and the object is found at some height above. So maybe the object's up here. Usually it's going to be written as GPE. That's what we're going to be using. But it could also be EP, the energy of the potential. And we're going to solve for that by mass times gravity times height. So the object has to have a mass, and then the gravity is due to Earth's gravity. So we're going to be using 9.8 or 10 in some cases, just because it's so close, it's easier to use 10. And then whatever the height is. All right, for this example, you have two skiers. As you can see, both of them weigh the same. And again, I am using weigh because we're talking about newtons here. We're talking about the force of weight. So they both have the same weight. However, as you can see, this blue skier up here is much higher. As a height difference. The blue skier is higher, so therefore it has more gravitational potential energy. Because it's higher up in the air. Alright, so to summarize, if we're going to be calculating kinetic energy, you're going to be using this formula. Ke equals 1/2 mass times velocity squared, and remember, it is only the velocity that is squared. If we're calculating the potential energy, we're going to be talking about gravitational potential energy. You're going to use this formula. GPE equals mass times gravity times height. I would write these down if you haven't already, because we are going to practice some of those equations. All right. So let's practice. Number 1, what is the potential energy? So, all right, we're solving for potential energy of a rock that weighs, so we have the weight, is 100 newtons. All right, so using our guess strategy, there are some things that we can go ahead and write down. We have some givens, and we already know our unknown. So our unknown, we are looking for potential energy. What we are given so far is that the weight is 100 newtons. And this rock is sitting on top of a hill that is 300 meters high. So we know that the height is 300 meters. And excuse my handwriting for these, I'm struggling to use the touchscreen part of my laptop. Alright, so you have a hint. Weight is not the same as mass. I hope you all remember that from past units. No, weight, of course, is not the same as mass, but we do know how to calculate it. So we know that weight is equal to mass times gravity. So we can plug in. The weight is 100. We're looking for the mass, and then times the gravity. Well, for gravity, let's just use 10. It's going to make our math a lot easier. We won't have to rely on a calculator. All right, so to get m on a side by itself, you're going to have to divide by 10, divide by 10. So that means that your mass is 100 divided by 10. So that's going to give you 10, and we're talking about mass, so kilometers. All right, so we know our mass is 10 kilometers. All right, so again, we're looking for potential energy. We have an equation for potential energy, remember? So we have potential energy equals mass times gravity times height. Now let's substitute. So we should have potential energy equals, well, the mass we said was 10 times the gravity, we'll be using 10, and then the height was 300. All right, so we have 10 times 10 times 300. So that means we're going to have 300, and then for every times 10 we add a 0. So 1, 2, we're going to add 2 more zeros. So we should have 30,000. We were looking for potential energy. So because we're looking for potential energy, and energy is measured in joules, it is 30,000 joules. That is the potential energy of the rock sitting at the top of that hill. All right, now we're going to find the kinetic energy of a bicycle with a mass of 14 kilograms, and it's traveling at a velocity of 3 meters per second. All right, so if you would like to use your guess, go ahead and fill it out on your paper. So we are given a couple of things. We know that the mass is 14 kilograms. We know that the velocity is 3 meters per second. Unknown. What are we looking for? Well, it says, what is the Ke? So we know that we are looking for Ke, or kinetic energy. There is an equation for kinetic energy. Remember, it is 1/2 mass times velocity squared, and only the velocity is squared. All right, so now we can substitute. So we go down here so I have more room. So we have 1/2 times the mass. The mass was 14 times the velocity squared. The velocity was 3, and we are going to square only the 3. Let's simplify. So if we do 1/2 times 14, half of 14 is 7, times 3 squared, that is going to be 9. So 7 times 9 is 63. And we were finding the kinetic energy. Energy is measured in joules. So this bicycle that is moving has 63 joules of energy. All right, number 3, a flower pot weighing, so we have a weight, 3 newtons, is sitting on a windowsill for 30 meters from the ground. So that's its height. It's 30 meters up off the ground. Is the energy of the flower pot potential or kinetic? And then how many joules is that? All right, so the flower pot, it is sitting. It is not moving. So that means it's going to be a potential energy. All right, so we know it's a potential energy. We know our equation is mgh, mass times gravity times height. We know that the mass of this flower pot, well, actually we weren't given the mass, were we? We were given the weight. The weight is 3 newtons. And again, we need to find the mass because they are not the same thing. Weight equals mass times gravity. So you're going to plug in 3 for the weight equals, well, we're solving for the mass, so you're going to have m times gravity is 10. Divide by 10 on each side. So you're going to have mass equals 3 divided by 10. 3 divided by 10. 3 divided by 10 is 0.3, or 3/10, and in kilograms. All right, so now we do know the mass. We know that the mass is 0.3 kilograms. All right, and we knew that the height, the windowsill is 30 meters off the ground. So we know that our height is 30 meters. All right, now we can go to plug in. Can substitute. So we know that PE equals the mass, well, we figured that out as 0.3, times gravity, 9.8, or I'm just going to use an easy 10, make my math easy, and then the height was 30. All right, so now we just need to solve. All right, if you use your calculator, 0.3 times 10 times 30 is 90, and we were measuring potential energy, so it is 90 joules. All right, number 4, when the flower pot in number 3 is only 10 meters. So maybe you relocate it slightly lower to the ground. It is now 10 meters. So we know the height is now 10 meters from the ground. What is the potential energy? So we're going to be looking for potential energy. Remember, it weighs 3 newtons. Well, I'm going to cheat. I'm going to go back. We figured out that the mass was 0.3. So we know that the mass is actually 0.3 kilograms. That was another given. Same flower pot, same mass. And we still know that gravity is 10 meters per second squared. All right, we know that to solve for potential energy, we do mass times gravity times height. So our potential energy should be, the mass was 0.3 times our gravity of 10 times our height now of 10. So that's going to give you 30 joules for our potential energy. All right, so if we compare 3 to 4, in question 3, remember the point was 30 meters off the ground. That's pretty high up. Our potential energy was 90 joules. Now you lower the flower pot. It is only 10 meters off the ground. Notice how your potential energy decreases. So when your height decreases, your potential energy does decrease as well.